So, Mo viewers, we got a cool one today. The electric motorcycle, electric race bike history is pretty limited, and so far it's kind of been centered around the Isle of Man TT, the TT0 race, where they do one lap around the Isle of Man as quickly as they possibly can. And that's kind of dictated how electric sport bikes and electric race bikes, which granted are a very small and limited field, that dictates how they're built, because to get around the Isle of Man, you need a ton of battery to do it. And so the engineering behind them has always been build as big of a battery as you possibly can, and everything else comes later, which then makes sacrifices on the geometry. That right there is a completely different way of thinking about the electric sport bike, the electric race bike, and I'm the lucky son of a gun who gets to ride it. Next to me is Brian Wismann. I'll give you the credit you deserve. He built the bike, he designed the bike, along with Eli Schless, who unfortunately couldn't make it here today to talk with us. Brian, you were telling me earlier the genesis for what we've named, or what you've named, really awesome title, the Lightfighter, yeah. Which I believe is a street near your house.
It's a street that I pass on the way to Laguna Seca every time I go to Laguna Seca to race, and I just thought,
what an awesome name for a motorcycle. I dig it. That's cool. So the genesis and the thinking behind the Lightfighter is that let's try and build a motorcycle, an electric motorcycle, where the geometry comes first and then the battery comes second.
Yeah, for the most part. So I've been building electric race bikes since some of those first runs at the Isle of Man in 2009, and certainly, like you said, the battery has always dictated the full layout of the motorcycle. So myself, I'm half of the team that built this bike. As you mentioned, Eli Schless from Ashland, Oregon, was the fabricator on this. We had some questions we wanted to answer about whether, if you looked at designing instead around the geometry, especially the rear suspension, and how you would optimally want to lay out the motor to transmit torque to the rear wheel, what that would do, whether the performance you saw on track would kind of live up to the expectation. And also those bikes that we mentioned before, those prototype bikes, tended to be rather heavy, and you needed a full team of engineers to support them. So the other question we wanted to answer was whether you could build a bike that was in the kind of super sport weight category and play the power to weight ratio game that way, and support it in a club race environment where you have some heroes here that are driving the van, being their own mechanic, racing the bikes, and then putting everything away in the garage and having to drive home. And could you make an electric bike fit into that kind of lifestyle and that pit environment, basically?
Right, and I think the racing environment, well, let's back up a second. Your day job.
Yes.
Is?
So I work at Zero Motorcycles. I get the opportunity to spend my day with the Zero Motorcycles engineering team designing some of the coolest electric street bikes in the world. And
You're not biased or anything, though.
I'm not biased at all, no. They are awesome. Check out the SRF. Yeah, my nights and weekends I spend thinking about how to make electric motorcycles go faster on the track. It's a bit of a, I guess, an addiction, you know.
Well, my point with getting to your day job was, for a street bike, a lot of the comments we see are, for electric motorcycles, is, you know, the range. Yep. Like, I can't go as far as I want to go on my, on my weekend ride.
Sure.
Which is not really a factor when it comes to an electric race bike, because you have a set distance that you're going.
That's right.
And you build around that to a degree.
Yeah, it's different requirements for sure between the street and the racetrack. And for the racetrack, you always know you're doing a loop, so you know ideally where you're going to end up, so you don't have to burden the bike with a big onboard charger. You can leave your charging infrastructure in your garage, because that's where the bike's going to end up. And really, you want to maximize performance and lap time over the course of whatever the race distance is. And for most club racing in the US, that's between 6 to 10 laps, and that's totally achievable with where we're at with lithium-ion battery technology.
So you touched on a topic about charging and how far you can go earlier. We'll get to that in a second, but we talked before that about building around the geometry, building a motorcycle with geometry first and battery second. So let's start with that.
Sure.
So yeah, what are the components on the bike? How did you come up with what we see here?
Okay. Yeah, certainly. So the Lightfighter it's a completely custom bike. So it's a custom frame, custom battery, custom motor. The thing that's not purely custom on it is the swing arm. So the swing arm is a 2015 plus Yamaha R1 swing arm, and no joke, I bought it on eBay. So it was the starting point. So I wanted to know if we could package traditional length. I mean, the R1 has great credibility from track riding performance, and so it was a good starting point. There were some other things about the swing arm that were nice to play with in terms of the packaging, but ultimately we want to know if you could package a traditional length swing arm and one with a linkage that allows for a lot of adjustability and tunability when it comes to perfecting the squat ratio, the spring rate, and the performance that you need.
Because the previous electric race bikes, say that went to the Isle of Man, that battery was so dominant, what happened to geometry then?
When you're optimizing around the battery instead, what tends to happen is that you end up with odd locations for the motor, and because of that, you end up with odd geometries for the swing arm. And so you see things like the motor tucked up under the swing arm, very short swing arm lengths, or no linkage at all, which then just gives you a direct linkage to do any progressiveness or digressiveness or tuning, and it kind of limits your range of tunability for a race motorcycle.
Okay. With that out of the way, because I'm sure people are like, well, why do you care about an R1 swing arm or a traditional swing arm in the first place? Let's move forward from the swing arm and just get to how the battery was, sourced, and the motor and the frame, and how all that comes together, because it is a one-off frame with pretty much one-off components everywhere.
Yep. So again, the chromoly tube frame and this custom lithium battery were fabricated by Eli up in Ashland. We had some performance goals. Primarily, we wanted to focus on weight for the motorcycle. So as I mentioned, we wanted to play that power to weight ratio game a little bit different on this bike. It makes about 120 horsepower, but it weighs 375 pounds, which puts it back into a super sport 600cc category power to weight ratio. So key to do that was to get a high energy density and power density lithium ion battery pack, which is what we have here. We have some good sources for automotive type lithium ion pouch cells, which is what this is built from. This is a 400 volt battery, so it is a high voltage battery. But other than that, the cells are arranged just in a 1P configuration, so it's fairly simple and straightforward as a build.
So the battery chemistry is similar to, say, what the automotive sector is using?
So this is about 1/10 the size of the battery as a Tesla Model S 100 kilowatt hour battery. So this is right around 10 to 11 kilowatt hours of energy on board. Again, what we're trying to do is maximize performance for an 8 to 10 lap race on this bike, rather than to maximize your range on a commute or something like that.
Moving down from the battery, you got the motor. Tell us more about that.
Yeah, so the motor is actually a pretty much off-the-shelf motor, believe it or not, from Parker Hannifin. They've developed since I believe about 2012, they've developed their GVM line of traction motors that have applications both in industrial uses, but also in hybrid and electric vehicles. And so we went to Parker with this concept. They've been a great partner. They do, as a matter of their normal business, they come up with a custom winding for the motor. So this bike has a custom winding. They come up with a custom length for the motor, and essentially what we've done is we've taken a off-the-shelf motor from Parker and then adapted custom end plates on either side that include a gear reduction ratio on one side and then a cooling plenum on the other, because the motor is water cooled. There's energy that you need to dissipate absorbing that heat energy with water is a great way to do it. So the bike has a 12-volt water pump. It has a water plenum that pumps water through the stator on the motor and up to a radiator, a traditional radiator like you'd see in a gas bike.
So the gear reduction is a pretty important piece. Tell us more about that and what it does and why it's important.
Yeah. So the gear reduction has really two purposes. One is to put the counter shaft where we want it to achieve optimum rear suspension geometry. And it's very similar in moving that counter shaft position to where you would expect to find it on a gas bike. The other is torque multiplication. So gearboxes are very effective ways to multiply torque. With the range of torque that we have in an electric motor, we don't need multiple gears to shift, but we do need to multiply the torque on the way to the rear wheel. This also gives you a few more options when you're selecting your final gearing. Say you're running at a track that has a very long front straight and you need a smaller rear sprocket to get the higher top speed versus tracks that are kind of shorter and more technical, maybe a little bit like what we're running here at Miller East, where we can gear a little bit shorter and achieve a little bit better acceleration.
Utah Motorsports Campus now.
Oh, that's right.
Yeah.
Sorry,
Anyway.
Utah Motorsports Campus. Yes.
Anyway, so with that being said, we're factoring in the gear reduction, how much torque is being applied to the rear wheel?
At the counter shaft, there's about 200 foot-pounds of torque being delivered to the rear wheel.
Say it again. Look over there and say it again.
So with this gear reduction, there's 200 foot-pounds of torque being delivered to the rear wheel.
On a 375-pound motorcycle.
That's right. Yeah.
And I get to ride it.
That's right.
Yeah.
Yeah. You're
pretty
doing
good.
a pretty good job. So. Yeah.
200 foot-pounds, 120 horsepower, 375 pounds, 55-inch wheelbase?
Yeah, it's around there. We've kind of fluctuated between 55 and 56 depending on the final gear ratio and the track that we're running at. Yep.
Oh, we didn't even get to the front of the motorcycle yet. Talk more about that. You got Ducati forks, but custom triple clamps.
Yeah, so the parts that are running on the front of this motorcycle came from a prior race bike that I was running. It's got Brembo brake, Öhlins FGRT 210 front forks. They're the Ducati version of the FGRT front fork. A great fork for the street and for club racing. And it's got a custom triple clamp that allows you to adjust the offset so you can change your trail and the front end feel a little bit.
So covering all of the mechanical, electronical,
all of the above.
All of the
yes.
above components. We've got very unique bodywork, I guess we could say, because it comes from our pals at Kramer Motorcycles.
Yeah, so as you mentioned, the bodywork on this bike is the Kramer Motorcycles bodywork. I think it's beautiful, just very distinctive lines. Kramer, as you know, but people watching may not know, build a really cool track-focused bike with a KTM engine. And so when Eli and I were thinking about building a very track-focused electric bike, naturally I reached out to the guys at Kramer Motorcycles USA, the guy, Joe Caravonen, and talked to him about the project. They were interested in supporting it. They mentioned that they don't know a lot about electric, but thought it was cool. So I'd say it's a loose relationship, but it's a very cool relationship. So they hooked us up with bodywork. There's been a lot of exchange of ideas in terms of building a very track-focused motorcycle and what a customer for a product like this might want to see. And I guess I'll just leave it at that.
Hopefully this can hopefully maybe cross fingers, find its way into more people's hands as some kind of maybe a kit or a production by somebody, Kramer. Who knows? But there was a topic I forgot to get to. When it comes to electrics, people always want to know about range. Well, we've covered that topic. We're only trying to do what a club race length is, 6 to 10 laps.
Yep, which is...
depending on the track.
Yeah, it's going to be anywhere from, say, 18 to 25 miles is a race distance.
And this Lightfighter can do that.
Yes.
We've already proven that it can do that.
Yep.
The next question people want to know is, how do you charge it?
Yep.
If your goal is to make a club racing electric bike or even a track day electric bike, okay, that's cool. How do you charge the thing?
Sure. So to charge this bike, we use a NEMA 1450 outlet, which is an RV outlet. So most of the tracks that we go to, I'd say all of the tracks that we go to, have RV hookups around the track, because that's how most people end up at the track with their motorcycles. So you plug into one of those outlets. It's a 50 amp outlet, so you can actually charge the motorcycle pretty quickly. And you know, I only see that electrical infrastructure growing as more people have electric bikes.
And charge time, generally speaking?
In a club race environment, you've got to turn around the charge fast enough to get out for the next practice. And typically at club races and on track days, you've got about an hour between sessions, and so that's the goal, is to be able to charge within that hour. And we've proven that we can do that and not have to miss sessions to give the rider plenty of time on track. So yeah, it's about an hour for a recharge.
And that's a wrap on part 1 of the Lightfighter LFR19 electric superbike saga. So now you know what it is, why it exists, and the thinking Brian and Eli put behind it to make it what it is today. All that sounds good on paper, and our testing at Button Willow has proved it to be a pretty effective package, but there's a whole lot more left to do, so follow along for part 2 as we continue testing and tuning and racing the Lightfighter here at Utah, but also at ARMA's biggest stage, the Barber Vintage Festival at Barber Motorsports Park in Alabama, where we really put it up against some of the best bikes and riders in the country. So again, follow along for part 2, where we continue on this electric superbike journey. See you on the other side. Hi, Mom! I'm riding a motorcycle.